So let's look at this. Here's our nice coordinate plane. We already learned about coordinate planes before. And so let's talk about this. The first question says, describe the location of the barber shop in relation to town hall. Now, here is the barber shop. In relation to town hall, where is that barber shop? Who can tell me? In relationship, where is that? Rocco. 3 blocks? 4, let's check. 1, 2, 3, 4, 5. We always start in the center. Also, it shows you a nice little dot right where it is in the center. So the barbershop is 5 blocks to the east or to the right of town hall. Now, the directions aren't as important when we're doing math, but this is north, east, south. Oh, they already have it at the bottom. They already have it right here, nicely. Okay, let's look at the next one. What building is located 7 blocks east and 5 blocks north of Town Hall? 7 blocks east and 5 blocks north of Town Hall. Who can tell me what building? Ben. The firehouse. Exactly. We would go 1, 2, 3, 4, 5, 6, 7. And then we go 1, 2, 3, 4, 5. And there we are at the firehouse. Excellent. The next one says, Violetta is at the library. Describe how many blocks and in what direction she should travel to get to the supermarket. So, currently, she's here at the library, and she wants to get here to the supermarket. Who can tell me one of the directions first? One just part of it. Oleg. 3 blocks south. Let's see. 1, 2, 3. Excellent. And who can tell me the next part? Michelle.
3 blocks east.
Let's see. 1, 2, 3. Exactly. 3 blocks east. Would it have been accurate to say she went 3 blocks east and then 3 blocks south? No?
Yeah.
Let's check. 3 blocks east. 1, 2, 3, and then 3 blocks south. 1, 2, 3. Yeah, it is accurate. She could go either way because we're still going to the same distance. We're still going to the same spot. Now let's see. Town Hall and the bank are both located on the same vertical number line. The number 0 represents the location of Town Hall on the number line. What number represents the location of the bank? What number represents the location of the bank on that vertical line? Elsie? 4, exactly. So now I'm going to ask you some other questions about this. We've done this before, and we've done some coordinate planes and graphing. Who can tell me the plot point, the ordered pair for the firehouse? Who can tell me the ordered pair for the firehouse? Let's see, Jenna.
8, so 7.
Mm-hmm. 7, and I'm gonna just show you really quick. 1, 2, 3, 4, 5. So it's 7, 5. Exactly. And that corresponds. Look at number 2. What building is located 7 blocks east and 5 blocks north? That's the firehouse. 7 blocks east and 5 blocks north. So our east and west correspond with our x-axis, right? And our north and south correspond with our y-axis. The north and south is also called the vertical line, and the east and west is also called the horizontal line. So I'm going to ask you guys something else. What building is at the origin? What building is at the origin, Lucy? Town Hall is at the origin. And what is the point of the origin, Lucy? 0, 0, because x is 0 and y is 0. When we start in the middle, how many places do we move over to get to Town Hall? 0. We don't move anywhere. So then, similarly, just like question 4 asked, what is the coordinate? What's the ordered pair for the bank? What's the ordered pair for the bank? Trey. The bank. What's the ordered pair for the bank? Who can tell me? Elsie.
The bank would be 4, 0.
4 comma 0. Now let's think. The first one is our x-axis. Our x-axis is how much we move. So what do you want to say it is?
0, 4.
Yes, 0 comma 4. It's a little tricky in the beginning to remember, but like I said last time, I remember x, y because x comes first in the alphabet and y comes second. Let's look further. So we're going to identify these now as quadrants. It sounds a little bit weird, but why do you think we call them quadrants? Who knows why we would call these quadrants? Hannah?
Because they're 4 is quad.
Yes, because it's split into 4, and 4 is quad. 4 is quad. When you have 4 babies at the same time, they're called quadruplets or something. Quadruplets, exactly. In Spanish, how do we say 4? Cuatro. In French, we say un, deux, trois, quatre, which doesn't help us at all. But here's the weird thing. Our quadrants, they go in a weird order. Notice how this is quadrant 1, and then this is quadrant 2, and then quadrant 3, and then quadrant 4. It's a little weird. First of all, that doesn't follow our normal left to right the way that we read, and it doesn't even follow our clockwise. It makes sense in further math why we do that, but we just kind of got to accept it at this point. I mean, that's just kind of what it is. So we look at our quadrants. And this is what's important. And I want you guys to write this in your book. This is what says on the back. In quadrant 1, our coordinates are positive and positive. So both the x and the y are positive and positive. For example, 2 comma 5, right? 2 comma 5. And that would be this point right here. Both of our x and our y are positive values. Both of our x and our y are positive values. Then, in quadrant 2, our x is negative, but our y is still positive. And we can remember this because with y, we're going up. And when you go up, you're positive, right? When you're feeling up, you're positive. So it makes sense. And when you're going to the right, you're positive. Like when you're learning, when you're reading, we read left to right. So we gain information, so we're positive going to the right. When we go to the left, we're negative. Next, in quadrant 3, what do you think our points are going to be? It says it on the screen if you're not paying attention. In quadrant 3, what are our points going to be, Elsie? Negative, negative. It would be this, because not only are we going to the left, but we're going down. And then lastly, in quadrant 4, our x is finally positive, but our y is still negative because we went to the right, but we went down. So that's how we organize it. That's how we organize our points. We're organized into 4 regions called quadrants, and we use these points to determine what quadrant they are in. First things first, I'm going to ask you a couple things. What quadrant is A in? What quadrant is A in? Rocco.
2.
It is in quadrant 2. What quadrant is D in? What quadrant is D in? Miles.
4.
4. What quadrant is C in? What quadrant is C, Hannah? 1. You had your finger up. What quadrant is B in? It's the only one left. What quadrant, Lucy? 3. Exactly. Once again, we go 1, 2, 3, 4. Exactly. Now, on top of that, I'm going to ask you guys, let's see. What is the ordered pair for C? What's the ordered pair for C? Elsie.
3, 3.
So that's a good guess, but look at the thing. It's look at the actual values down here. Exactly. So it's 1.5 and what? 1.5 and 1. Exactly. So sometimes on our graphs, they're at a different scale. It doesn't always have to be 1. So we always have to pay attention for that. What about A? What is their value for A? Who can tell me? What is it, Roman? So what is the value, Anita? -1, and then our Y value is? 1.5. Exactly. Exactly. Notice how in each one, this one, our x and our y were both positive. In this one, we had a negative x and a positive y. What about for B? Taking a guess. What about for B? What kind of values are we going to have for point B? Lucy? Both are going to be negative, and can you tell me what the values are?
1.5, negative 1.5, -1.
Perfect. Exactly. Look, they're both negative. Exactly. So that's how we do points in the coordinate plane. We can use our knowledge of the coordinate plane. We can use our knowledge of the quadrants and what kind of values they are to double check our work and make sure that what we're doing is accurate. So here's something that sounds a little bit challenging, but it's actually not. We're looking at this. Reflections on the coordinate plane. So this isn't a reflection like thinking back and reflecting on your past behavior, but I like to think of this reflection more like a mirror. So if this was our mirror right here, and we were looking into it, we're looking in from this distance, the opposite would be from that distance, right?
Yes.
Exactly. I also like to think about it where if we had this and we folded it in half, boop, the two things would be the exact same. They would touch. So a reflection about the x-axis and a reflection about the y-axis. That's what we're doing here. So if I folded this in half, which axis would I be folding it on? If I folded this in half, which axis would I be folding it on? Who can tell me? Would I be folding it on the y or the x, Ben? The y-axis, because you see how it's the up and down that I'd be folding in half. So that's why it's reflected across the y-axis. It's reflected across the y-axis. It's a little confusing. The y-coordinate doesn't change. That's why it's reflected. It's mirrored on both sides. But our x-coordinates are opposites. So for example, we see this point over here. Y is 0, but x is 4. When we reflect about the y-axis, our y point stays the same. It's 0, but our x now flips. It's -4. Does that make sense? Yeah. It's a little tricky at first. Now, let's think about this one. This is reflecting across which axis? Who can tell me reflecting across which axis? Let's think. Roman. Take a guess. What's your guess, Roman? Say it out loud.
X.
Yes, the x-axis, because here, if we folded it, we would be folding it across the x-axis. Yes, you are correct. So notice that our x value does not change. Our x value is the same for both of them, but our y values are opposite. Also, notice when we reflect, we're reflecting across the literal axis, right? What happens if I add 2 and -2? Technically, what I would write is 2 minus 2. What do I get?
2.
What do I get? Everybody say it out loud.
Raisins.
What do we think? We get 2? What do we think we get, Roman?
7.
So notice that when we combine those two, we get 0. Let's look back at this other one. 4 and -4. What happens when we add 4 and -4? What do we get? 0. So for example, if I have $4 and then I spend $4, how much money do I have? 0. That's what these reflections mean. They mean when you reflect it, you get that same distance, So I want you guys to try C, D, and E. I want you guys to try C, D, and E on page 397. So if you're flipping something across the x-axis, which value changes? If you're flipping it across the x-axis, which value changes? Who can tell me? Raising our hands, if you're flipping it across the x-axis, which value changes, Anita? Well, which one is that called? Which value, x or y? Which value changes if you're flipping it across? the y changes. If you're flipping it across the x-axis, the y changes. I know it sounds confusing because you're saying flipping it across the x, you think automatically, oh, the x changes. But all we're doing is we're opening it kind of like a book. We're closing it like a book. The x's stay the same. So let's look. If our x's stay the same, what's our x going to be for the first one? Who can tell me what our x is going to be for the first one? Our x. Trey. Our x for the first one for letter C. Ben. 1, because our x stays the same. And then our y turns opposite. What's opposite of -4, Rocco? 4. Exactly. Let's look at the next one. If our x value stays the same, what's our x value for the second one, Ben? -2, and now we change the y to -5. What about for the third one? Who can tell me for the third one? If it stays, our x value stays the same. Our x value stays the same. What do we get, Michelle? -3 and 1. Exactly. The only value to change is our y value. Now, what if I was doing this and decided to flip it across the y-axis? If I want to flip this one across the y-axis. So, what would our first ordered pair be if I'm flipping it across the y-axis, Hannah? -1, -4. Because we're flipping it across the y and the y stays the same. What about for our second one? We're flipping it across the y-axis, Miles. 2, 5. What about our third one if we're flipping it across the y-axis, Lucy? 3, -1. Exactly. So that's how we do this. We're flipping it across the axis. I want you guys to start doing the guided practice, and I'm going to come around and help you as needed.